Hello. Today we are going to simplify the following integer exponent expressions that are listed here, and we are going to apply some of the laws of exponent properties that were covered in my previous video lesson. Okay, let's get started with our first expression here. We have 2 times a raised to the negative third power times b raised to the fourth power, all being raised to the fourth power. Now there's several ways we can work this problem out, but what we're going to do is we're going to take each individual value or term and raise it to the fourth power. So first we'll do 2 raised to the fourth power times a to the negative third power raised to the fourth power times b to the fourth power raised to the fourth power. So when we break down each term, we have 2 to the fourth power, that's 16, because we know that 2 times 2 times 2 times 2 is equal to 16. Then we have a to the negative third power raised to the fourth power. Now the power law of exponents, it states that when you have an exponent raised to another exponent, you multiply those two exponents. So now we have a to the negative 12th power. Now if you didn't get a chance to see my previous video lesson covering the laws of exponents, please check it out. I'll leave a little note card on the screen here where you can reference that video. Okay, and last we have b to the fourth power raised to the fourth power, and we'll get b to the 16th power. Okay, now we can simplify this even further. Now if you look at this term here, a to the negative 12th power, that can be simplified using the negative law of exponents. And that exponent says when you have a non-zero number, a, raised to the power of a negative number, you can rewrite it as the reciprocal of that number to the positive value of the exponent. So the reciprocal of a to the negative 12th will give us 1 over a to the 12th. Okay, and then we just bring down or bring over the b to the 16th. So our final solution here would be 16 in our numerator. In our denominator we have a to the 12th, and here in our numerator b to the 16th. So final answer 16 b to the 16th power over a to the 12th power. Okay, now moving on to our next expression here, we're going to evaluate negative 7x squared times y to the negative third power, all raised to the second power, times z cubed times y, all raised to the negative fourth power. We are going to solve this in the same manner as the previous problem. So first we'll start with negative 7. We're going to square that. And then x squared, we're going to raise that to the second power, times y to the negative third power. We're going to raise that to the second power. So then we're going to do our next term here. So times z cubed, we're going to raise that to the negative fourth power, and y, we're going to raise that to the negative fourth power. Okay, so when we evaluate our first term, we have negative 7 squared, which is 49. X squared raised to the second power, that's x to the fourth power, because when you have two raised exponents, you multiply them. And now we have y. When we multiply negative 3 times 2, we get negative 6. Then we have z raised to the negative 12th power. And then we have y raised to the negative 4th power, because right here y, the exponent here is understood to be 1. So 1 times negative 4 will give you negative 4. Okay, when we look at this expression, we see that we have two y's. We have y to the negative 6th power, and we have y to the negative 4th power. Now, if you can recall, the product law of exponents states when you have two bases that are the same, which we do here with the y's, what you do is you can add the exponents. So we're going to add the exponents here. So a negative 6 and a negative 4 will give us a negative 10. So I'm going to go ahead and bring over the 49x to the 4th, and I'll just combine these two terms here, and we'll get y to the negative 10th and times z to the negative 12th power. Okay, let's move on to our final stage of this problem. So now we have 49 x to the 4th. Now let's take a look at our y as well as our z. They're both negative exponents, but let's recall the negative exponent rule. Okay, that states if you have a number other than 0 raised to the power of a negative exponent, then you can rewrite it as the reciprocal of that number. In our case here, we have y and z, and raised to the positive value of that exponent. So what we're going to do is we're going to take the reciprocal, starting with y to the negative 10th. The reciprocal of that will be 1 over y, and they say change the exponent to the positive value, which would give us to the 10th power. So we have 1 over y to the 10th power, and for our z to the negative 12th power, the reciprocal of that is 1 over z to the 12th power. So now our final answer will be, now let's keep in mind we have numerators and denominators here. So in our numerator we have 49 x to the 4th over y to the 10th times z to the 12th. And this is our final answer. Next up, we have c to the negative 3rd power times d over 8 times d to the negative 4th power times c to the negative 5th power. So we're going to use the quotient law of exponents to solve this problem. And that states when you divide two numbers with the same base, you can subtract the exponent of the divisor from the exponent of the dividend. So in this problem, you see we have c to the negative 3rd power, and we have c to the negative 5th power. They're the same, so we're going to subtract the exponents. So for c, we're going to have negative 3 minus a negative 5, and the value of that gives us 2, because a negative 3 plus 5 is 2. Now let's go ahead and do the same for d. So for d here we have d to the first power and d to the negative fourth power. So we'll subtract. We have 1 minus a negative 4, and that gives us 5 for the exponent for our d variable. So here we have c squared times d to the fifth power. So now we're left with an 8 in our denominator. So this is our answer, or we can rewrite it as 1/8 c squared times d to the fifth power. Okay, so we are going to wrap it up with this final problem. G to the negative third power divided by G to the negative second power times F to the negative fourth power, all squared. Okay, so let's look at our like terms here. We have G to the negative third over G to the negative second power. We're going to use the quotient law of exponents rule, and we're going to subtract those exponents. So for G, when we subtract negative 3 minus negative 2, we get negative 1. So now we'll have G to the negative first power divided by F to the negative fourth power, all squared. Okay, so now we can use the negative exponent rule, and we are going to find the reciprocal of each term. So the reciprocal of G to the negative first power is 1 over G, and the reciprocal of F to the negative fourth power is F to the fourth power. So basically our terms flip. Our F goes to the numerator and our G goes to the denominator. And keep in mind, we are squaring the entire term. And actually we're going to break that down. So F to the fourth power squared over G squared. And our final answer is F to the 8th power over G squared. I hope you gained value from today's video lesson. If you haven't already done so, please like, share, and subscribe to my channel. Until next time, happy learning.